Okay, everybody, welcome back. It is 1:30 Central European Time, and let's get started on the next bit of the demo. Let me start the recording.
This meeting is being recorded.
Okay, because I have OCD, I needed to figure out why I couldn't log into my MSO, and I figured out why. Well, the first answer is because I'm an idiot. Real answer, the technical answer is I forgot that MSO 3.01, the one I moved to, was running on the virtual application services engine. I forgot. And in order to get to the CLI of the application services engine, you have to log in as rescue user with the password that you set when you installed the virtual application services engine. So that's what I've done here. I'm logged in. I think I'm logged in as rescue user here on my virtual services engine where my MSO is. And so I told you the command was ACI diag health. Now, that's not quite the whole story. So let me correct myself. ACI diag health checks the cluster status. So remember you have like 3 cluster members and they form a Kubernetes cluster, blah, blah, blah. ACI diag health gives you the cluster health. For MSO, the command is ACI diag app show. And if I type that command, you see this output here. Now you'll notice I actually have 2 apps. I have the old version 3.099, which you can see is in admin state disabled. That's not the one we care about. The one we care about is this one, 3.01i, which is the one that's enabled, admin state enabled, operational state enabled, and it is running. That's a quick way to tell, like, while you're waiting for your thing to upgrade or do something, this is a good, easy command to kind of check, like, is it still going through its spin up and do I just need to be patient? Or is something wrong? This could give you a clue here. So I just wanted to correct myself with that. So putting that to bed, let's go on to the next set of demos. So Max, if you remember in his lecture, talked about schemas and templates and all that business. Now, that's a really important and fundamental topic that we need to spend some time on to make sure that we get it right, because this will be the area where you will be spending most of your time in Multisite Orchestrator. I think I mentioned earlier that, at least in my head, MSO gives me 2 fundamental things, right? It does 2 fundamental jobs. The first job is it sets up the data center interconnect for me. So we saw that already with infra, that's done. We saw how easy that was. The second major sort of fundamental job that MSO does for me is it acts as a central repository for tenant level policy. So when I want to configure VRFs, bridge domains, EPGs, contracts, and do all that kind of stuff, I do that through MSO. It becomes my central policy repository. Once I build my policy in MSO, then I get to decide, where do I want that policy to live? On site 1, on site 2, on both? How do we want to do it? MSO is, giving you all options that you need there. So that's what we're going to focus on here, is that sort of second fundamental idea about the notion of MSO as a policy central engine for ACI tenant level stuff. So what am I going to show in this demo? Well, we're going to do a couple of things. We're going to create a new tenant inside MSO. Then we're going to set up our first schema. So we're going to kind of go through what is a template, what is a schema, and we're going to see it, right, to cement your knowledge from Max's lecture. Then we'll go through and with that first schema, what we'll do is we'll set up 2 different examples. One will be a greenfield template example where nothing has been configured. This is all brand new stuff. And we'll configure MSO, we'll push it to our sites, we'll show you what that looks like. We'll talk about the use of templates in more detail. Then what we'll do is a second example where we'll set up a brownfield scenario where, let's just say we have a site 1, and let's say long before Multisite came along, we had a tenant running there operating just fine. And then later on, we come along and we say, Multisite, that's what we want. And we set up Multisite Orchestrator and off we go. What do I do with that existing tenant? Well, you have the option. It's not required, but you can import that and tell MSO about it. And from that point forward, MSO becomes your point of management for that tenant. So we can import things, and we can even import and move across to different sites if we want as well. So we'll try to show you that with the brownfield tenant as well. So this is my lab. We already know what that looks like. I'm missing the multipod thing, but ultimately we've got our two sites, and that's what's going on. So what I'm going to do, just for sake of we understand what's going on, is for schema number one, this is going to be my greenfield template, schema and template for greenfield environment. So I'm going to create a tenant, brand new tenant, never existed before, called green. I'm going to build a VRF, and I'm going to make some contracts and filters. Now, what I'm going to do is I'm going to build that policy, and I'm going to push it so that tenant green lives equally in both sites, Amsterdam and Barcelona. The same thing will be true. They'll be sharing a common VRF, and that VRF will live equally in site one and site two. And the same will hold true for contracts and filters. Then what I'll do is specific to Amsterdam, I want to build a bridge domain with some subnets and a couple of EPGs that only live in Amsterdam. Those subnets, those EPGs should only live in Amsterdam. So I'll build that in MSO and I'll push it, right? Alternatively, in Barcelona, I'm going to build a different bridge domain with a different network and different EPGs that only live in Barcelona, period, right? They only live there. And then what I'll do is I will establish connectivity. Sorry, I will establish, well, I'll actually, in the next demo, I'll actually establish connectivity and show you what that looks like. But for now, I just want to focus on schemas and templates. So in this particular example, I think Max showed it, and I'll remind you here, is when we deploy in Multisite Orchestrator, we have a couple of choices about how networking works at the bridge domain level. And I think Max showed some version of this slide. But on a per bridge domain level, you have a choice. You can say, listen, I only want layer 3 routing. So I only want to route across the ISN. Each site will have its own independent network. So site 1 has network red, site 2 has network green, different EPGs, different networks. And I just want to route between them. Basic routing, right? That's what I'm setting up with my greenfield tenant. There's a second choice on a per bridge domain level of IP mobility without bum flooding. We don't want to flood traffic here, but we still want layer 2 adjacency at some level. What does that mean? Well, and I'll set that up a little bit later, but you have same tenant, same VRF, but network teal lives equally at the same time, same network lives equally in both sites, and we will establish that, but we will tell MSO when it sets it up not to allow the flooding of bum traffic. But we can still do things like vMotion, which does require layer 2 adjacency, and we've sorted all that out and it's working well. So this is probably one of those cases where you need layer 2 adjacency, but don't want to, flood traffic because that would be inefficient. Your third choice, which I won't show, but I won't build, but I'll show you how you do it, is the same kind of notion where you have the same tenant, same VRF, same network, same bridge domain, equally living across both sites, but you want to flood that layer 2 traffic. That's probably a more rare corner case, and it's probably not the first place you should go. But if you have a case where you absolutely need layer 2 adjacency and you need to flood traffic, like some sort of weird app that clusters with layer 2 multicast packets or something, you have that option, right? But really, option 1 and option 2 are going to be your go-to options, but you have a third choice if you need it. Okay, and I'll show you what that looks like. So let's do schema 1 now here. So let's go back into Multisite Orchestrator, and of course I got logged out. It has a timer that I cannot change. That's a feature request, Max. Allow me to set my timeout. Okay.
Hold it down.
Right. So we're back here in our new MSO. Everything's working. Where do we go for actually building tenant level policy? Well, that's going to be under application management. And you can see here we have tenants, we have schemas and policies. We're going to be focusing on tenants and schemas here. Now, remember, in my case, in my greenfield tenant, brand new tenant, never existed before, I'll create tenant green, I'll create a VRF for tenant green, and I want them to live in both sites. So the first thing I need to do here is actually create the tenant called green. So in the tenant section, I can quickly add a tenant, and I can give it a name, tenant green. down here, it's asking you which sites do you want tenant green to exist in. And in my case, I want it equally in both. That's really it. So I'll go ahead and say save, and I have actually created a tenant. In fact, if I go here and I show all tenants, you'll see there is tenant green. And notice, let me zoom in a little bit, tenant green has a little extra MSO icon. So notice this is an indication that this is an object or a tenant that was pushed by Multisite Orchestrator. And if I click on it, yeah, you get that warning there, or that informational alert that this is a multi-site object, and then of course you see the icon as well. So, and that of course also equally exists in Barcelona as well. There's tenant green, and it's the shell of the tenant is there for us to use. So what do we want to do next? Well, we want to build some objects that live equally in both sites, namely a VRF that we stretch across both sites, same VRF, and some filters and contracts. So where would we do that? So we can go into schemas. Now remember, Max said schema is really just it's an organizational concept. It's a folder where you can put a bunch of templates that are, let's say, go together, that are related together. So I'm going to add my first schema. I don't have one. You can give it a name, and I'm going to call this guy Greenfield. Whatever you want to give it. I need to learn how to type. Okay, did I spell field right? I think I did, yeah. Okay, so here I've got Greenfield. Down here, I've got a series of templates. Now, a schema can have one or more templates. In fact, it'll be very common that you'll have multiple templates for a given schema. It's normal, right? So don't think it's a one-to-one relationship. So I've got template one here already sitting there out of the box. I can click on the little edit icon and give it a name. So what I'm going to call this template here is I'm going to call it common items. You can call it whatever you want. And the reason why I'm calling it common items is because I want to put the stuff here that lives equally in both sites at the same time. So we've got our template sitting here. The first thing we need to do is select a tenant. Let me see if I can kind of zoom in a little bit. That's ugly right there. Okay, select a tenant. So if I click there, it's going to basically pull a list of tenants from the tenants part of MSO, and there's my green tenant, right? So I bring him in, telling it this is the tenant that I want to work with. So what are the things that I want equally to live in tenant green in both sites? Well, in this case, I want a VRF. So I'll click on VRF, and I'm going to call this one V1, right? Just whatever name you want. That's pretty straightforward. Then I think I want some contracts and filters, right? So let's actually build a contract here. And I'll call that contract C1 because I'm a creative type. And then I'll create a filter. And I'll just say, what do we call this? Everything, right? I learn how to spell. No, okay. I don't know how to spell. So notice here, I'm clicking to select a filter, but I don't have one. But you see it says select or create filters. And if I want to create one and I learn how to type and I hit enter, now I've just created one. Okay. And then I say save. You see, there's my everything. So what I need here is I want to add a filter to that, right? Now I don't really have any filters, so I'm going to create a filter called all, right? Hit enter and say save, right? You'll notice down here, oh, actually, I already built the filter called everything. Delete that one. There's everything. Now I need to actually define what's in the filter called everything. So I'm sorry if that was confusing. So I'll call that one all. And I'll just I'm basically going to allow everything. Like you can go in and say allow IP, allow TCP or UDP, port, source port, destination port ranges, standard ACI contract business, which we assume you already know. So with this setup of unspecified, it's basically everything layer 2 and up is allowed. Just for easy contract business, I don't want to be troubleshooting. Did I open up port 80 when I didn't mean to or something? So there is my my filter that's allowing everything attached to my contract. I don't need that. Okay, so I've got my filter, I've got my contract, I got my VRF. What does that really look like? That looks like, sorry, that is this, right? This is what I'm doing right now. So we've got our template called common items. We can click save. It does auto save as well, but Everything is good. If there was an error, and I'll create some errors later, but there would be a red box around it telling you, hey, you missed something. You gotta correct something. So at this point, all I've got is a template. The next thing I need to do is I need to tell MSO which sites I should push this template to. So I'm gonna click on the template itself on the three little dots, say add sites, and I want it to actually live equally in both. So I'll go ahead and click save. Now, have I actually pushed to the sites? Not yet. I've only made the association in MSO because you'll see you get this little yellow triangle, and if you hover over it, it says changes made to the template have not been deployed to the site. So how do we do that? Well, we click deploy to sites. So when we click deploy to sites, Max kind of showed you an image of this, but we want to let you know before we deploy what exactly is about to happen. So this is like a last time to check that you got it right. So you can see here, I'm creating an object. It's a VRF called V1. It's going to be created versus deleted or modified in both Amsterdam and Barcelona. And the same is true for the filter and the contract. So assuming everything is as you want it, you can then safely click deploy. And you'll notice in just a moment, the little yellow triangle goes to a green checkbox, and that means it is, in fact, deployed. So let's go back to Amsterdam here, and we can see our tenant green, and we can see here we've got a VRF called V1, and we have a contract, a standard contract called C1 right there with the filter. Yeah, so everything is looking good so far. So back to MSO. So what's the next thing I want to do? Well, the next thing I want to do is I want to create the Amsterdam specific bridge domain EPGs and subnets. So how am I going to do that? Well, let's think about this for a minute. Should I use the template called common items to do that? I don't think so, because this is Amsterdam specific only configuration. So what would my option be? Well, simply create another tenant. So what I'm going to do is I'll create a second tenant, and I'll call this Amsterdam only, whatever you want to call it. Again, just like before, I have to tell it which tenant are we working with, because note that a schema will let you have multiple templates, and you can actually do it for many, many different tenants. Now, Max will tell you, probably map one schema per tenant and have any number of templates that you want for that tenant. You can do more sophisticated things, but just from an organizational point of view, that's probably a good way to start. And as you get more comfortable and you want to get fancy and sophisticated, yeah, go to town. But as long as you know the fundamentals, we're happy, right? So we'll select our tenant green once again. In this case, what do I want? I want a bridge domain with some networks and a couple of EPGs. Okay, let's do that. So the first thing I'm going to do is I'm going to create a bridge domain. I'll call this one BDAMS. Of course, we need to attach that bridge domain to a VRF. If I select VRF, notice it gives me a list of available VRFs inside this tenant. And you notice there's V1. Well, where is V1 coming from? Well, it's coming from the common items template. So it shows up as a choice. So select there. Now it's important. This next little area is quite important. Remember those three options I showed you? These three options, right? Remember that? On a per bridge domain basis, we need to make a choice here. And let's understand the choice we're making. If I leave these on all three by default, which one is that? That is number 3. That's that one. That's not what we want for this particular scenario. So I am going to untick this box, right? And it will tell you if you had any subnets configured in MSO, they'll be removed, blah, blah, blah. Do you want to proceed? Yes. I haven't pushed this yet, so this doesn't even exist. So nothing's changing. So notice it turned off everything. So now what do I have? I have this set up. That's how I'm setting up this particular bridge domain, option 1, by unticking the box. But what something changed, and it was quite subtle, but this is probably an area where you will get confused the very first time. So let's explain it since we have some time. I'm going to click the layer 2 stretch button again, just for fun. I'm going to uncheck it later, so don't get nervous. When I tick the layer 2 stretch, notice down here there's a gateway IP, and this is where I would assign my bridge domain subnet, like 192.168.1.1/24, right? When I untick that box, so this box says this bridge domain will live equally at the same time in both sites. If I untick the box and I go back to option number 1, where I say this bridge domain is only going to live in Amsterdam, it is what we call site specific. Notice the little subnet thing has gone away. Oh my God, where did it go? I can't configure my bridge domain subnet. I will show you where we actually do that at the site-specific level. So hold that thought for a second. Let me finish with my EPGs and I'll show you where all that happens, okay? But just note, you're going to get confused there the first time when you do site-specific things. So I've got my bridge domain. It's attached to VRF v1. Let's add my EPGs. So I'll add an application profile. Call this AMS. I'm going to add some EPGs. So I'm going to call this clients AMS, right? And I'm going to tie it to a bridge domain. There's my BD AMS that I just created. All good, all good. For now, I won't do a contract yet. We'll do that a little bit later, but basically I have my EPG. So you're also probably wondering, what about like VMM domain mappings and stuff like that? Where does that live? Again, hold that thought. I'll show you that we do it at the site-specific level settings. I'm going to create a second EPG, and I will call this servers AMS. Again, attach it to the same bridge domain, and off we go. So I'll go ahead and save this just for to make sure we're good, right? So there's my template. So basically I have done this, yes. So let's go a little bit further and finish the site-specific settings for Amsterdam only. Just like common items, we haven't attached this particular template to any given site. So let's do that. Add sites, Amsterdam only one site. Notice it shows up down here. This is what I mean by site-specific settings. There are certain settings that are only relevant and show up in Amsterdam that don't show up in Barcelona. One of those things is the bridge domain subnet. So here we can see at the site-specific level, bridge domain, scrolling down, there is where we configure the subnet. Are we following? You do it at the site-specific level. So just like before, you can set up a subnet. You can add a secondary if you want. We'll make a secondary subnet for fun. And we'll say save. So there's my subnets for the bridge domain. Good. Now let's go down. Up to the EPGs, right? Now, what I want to do here is I want to make a VMM domain mapping to this EPG, right? So just so you're aware, I have already, ahead of time, created a VMM domain in ACI. This is standard ACI 101, right? This is we assume you know how to do this. I've already got a VMware integration going on in Amsterdam called VC DVS. Already exists, I've already done it. And I have a fault. Yeah. Okay, we'll see if this works. So back here in MSO, I'm sorry, this is my vCenter view, and you can see there's my DVS. So let's go back here. I want to map clients AMS to use that VMM domain, right? So where do I do that? Somebody very early on in the Q&A was saying, there was two people asking about, how do I do mappings to an EPG, whether it's a static port binding or a VMM domain? And someone even said, I don't even have the capability to do a static port binding. I stayed quiet on purpose because I wanted to show you that you do have that under the site-specific settings, right? Static ports, static leaf if you want it, and physical domain bindings or VMM domain bindings. You see? So I'm going to make a VMM domain binding. It's going to query the APIC and say, give me a list. In this case, I only have one. So I'll select there. Deployment immediacy, your choice, on demand, immediate. I think the default is on demand. We'll say save. So I've now just bound clients AMS to that VMM domain. Let's do the same for servers real quick, just so you cement that. I'll go faster and save. So there we go. So we've done our bridge domain subnets. We've done our EPG mappings to a VMM domain, and we will save. Now, has this been pushed? Not yet. There's the little icon. We need to deploy. Where's the deploy button for AMS only? Well, it's up here at the template level, the top of the template. We'll go ahead, deploy to sites, triple check that everything is looking good, and we will say deploy. And in a second, that will go green. If we go here, back to our tenant, where's my tenant green? Yeah, sorry. There's my ANP. There's my two EPGs. There is my domain mapping. When I go back to vCenter, I know I'm going fast. There's my, sorry, can I make it? Okay. Tenant green, ANP called AMS, EPG name. That's the format, right? So you can see there's clients, there's servers. We're in good shape, right? Now, what's the next thing we want to do? Well, the next thing we want to do is we want to do something specific for Barcelona. Well, that's more or less the same thing, right? How would I go about doing that? Could I use common items or Amsterdam only? No. I want to create something that's Barcelona specific. So I'm going to create a third template just to show you that you can create, what is it, up to 10? How many templates per schema, Max, was it?
Tenants per template per schema 10.
10,
from
okay.
yes, from 2 to 4.
Okay, got it. So I'm going to select my tenant green. I'm going to do the same thing. I'm going to go faster because we've already seen this, but I just kind of want to cement these things. We'll create our bridge domain, and we're going to call this bridge domain BCN. Map it to the same VRF. Make it a layer 3. So untick the stretch box. Let's create our EPG and call this client. Let's just make one for sake of time. Servers BCN. Yes, I don't know how to spell. Attach to the bridge domain. Notice it's aware of both bridge domains because they're part of the same schema, but make sure we pick the right one. And yeah, that's that one done. Bridge domain done was saved. Now, just like before, we map it. When we're done, add sites, sorry. This one's Barcelona only. Notice it only shows up under Barcelona. And I need to make some of those same changes. So I need to put it, I need to give the bridge domain a subnet. In this particular case, it's 192.168.3.1/24. And we'll say save. Same kind of thing. I need to do a mapping of the VMM domain. So under the EPG at the site specific level, under domains, I'm going to map. I know I'm going fast, but this is just a repeat of what I did for Amsterdam. But notice something here. Domain profile. Where is VC_DVS? Well, it only lives in Amsterdam, right? It doesn't live in Barcelona. It'll never live in Barcelona. It only lives in a different VMM domain called VC Site 2. Where's that coming from? Going to the APIC in Barcelona, I've already set this up ahead of time. This VMM domain already exists, and there it is, VC Site 2. This only lives in Barcelona, okay? So, but that's okay. It's going to work, right? MSO does all the networking stitching for us. So we'll make our choices, and we'll say save. Save this, just for good measure, and we need to deploy. So clicking at the template base level, deploy to sites, and there we go. In just a second, yeah, okay. So now if we go back here, we look at our other DVS. I have one vCenter managing both, by the way, but here's my tenant green, ANP called BCN, and then my EPG name. You see, it's just that easy to do this. In this case, greenfield is probably the easier thing. So that's, I think, let me just make sure that, yeah. The next thing I want to do is I want to do a different schema. I want to import an existing tenant, right? So this is a scenario where I think, did I do this as a build? Yes or no? So yes, so do that later. I had an existing tenant before MSO came along. And then I deployed MSO sometime in the future, and I set up my infra, blah, blah, blah. I'm here where I'm at right now. And now I want to bring in that existing tenant that was, just in a single site before. I want to import it. I want to import it into MSO and manage it from MSO from this point forward. In fact, I might even want to modify this tenant in MSO and move some things over to Barcelona, right? So we can do that as well. So one of the things that I want to also do is have another BD called BD Stretch that currently only lives in Amsterdam, right? So I'm going to build a new tenant with a new VRF. The names I chose were the same as my other EPGs, but this is a wholly different new tenant, right? It's just for my sake of consistency. But I'm going to build a bridge domain EPG and BD Stretch, right? And it's going to be in tenant brown. And let's say I've got some contracts and filters already existing. What I want to do is I want to import that into MSO as the first thing, right? So it's already kind of pre-configured and now it's in MSO. Then what I want to do is I want to take tenant brown and say, well, I've added a second site in Multisite and I want to stretch tenant brown. I want to stretch VRF v2 to live equally in both sites. And I want to stretch my contracts and filters as well. And then what I want to do is I actually want to take this BD called BD Stretch, the purple one, and I basically want to say, now what? Wait, when did I? Sorry, I forget. Hold on. I must be okay. I'm sorry. What I wanted to do there is take that BD Stretch. Sorry about the order. I want to take it and I want to have these objects now live across both sites. Okay. So let's actually go and build that. So I think, sorry, I had deleted tenant brown, or not deleted, but I wasn't done configuring it before lunch was over. Let me just make sure that I have, we can delete this. Sorry about that. I was trying to get it all configured and no excuse, but let me create that bridge domain. So BD stretch. Oh, in this case, it's VRF v1. I'm sorry, I said it was v2, but it's a different tenant, it's different VRF altogether, just the same. Well, let's do this. Let's actually create v2, just because we can. So it'll be our VRF v2, and we'll say next. This one will be, what did we say? Sorry, this is stuff I should have had done. So you're seeing me do an embarrassing amount of work that I should have already had in place. And we need another BD. What did I call it? I called it BD stretch, or EPG stretch. And we'll tie this guy to BD stretch and go. And I think I've already got some contracts and filters. Contract 1. And let's see, I've got some filters here, basic filters. Yeah, okay. Okay, sorry about that. So that should have already been done. This is, again, just so that we clear the confusion, this is a tenant, brownfield, that already existed before we installed MSO, and now we want to import it into MSO now that we have it running. So let's go ahead and close this schema. I'm going to create a new schema because this is a new tenant, right? I don't have to, but it's probably better organizationally just to map one schema per tenant and then have your templates underneath, that. So I'm going to add a second schema, and I'm going to call this guy brownfield. And just like before, I need to select my tenant. What's going on? Where's tenant brown? Interesting. Where is tenant brown? Well, I'm not ready to actually build a schema. I screwed up, which is probably good that I did, because we need to do something for it. I know Max was shouting into his muted microphone and saying, you forgot the tenant. So let's go under, what is it? Infrastructure, where is it? Sites.
Yeah.
So, there we go. Okay. In Amsterdam, this guy Brown, this tenant Brown already exists, yes? So what I want to do is on Amsterdam in the sites area, click on the three dots and say import tenants. There's my good friend Brown, and I'll say okay. And now under the tenants area, you will see that Brown has shown up, right? At this moment, I only want Brown to live in Amsterdam. How would I check that? Well, clicking on the tenant, three dots, and we can see that right now it's only living in Amsterdam. That's okay. We'll change that later, but that's how I want it. So let's go back to my schemas. Let's add my schema and go to Brown field. And now click my tenant. Where is he? There he is. There's Brown. Okay. So let's call this guy. What did I call this one before? I guess we can call him AMS only. Again, whatever. I know I'm not creative, but so how do I actually get those objects into MSO? Well, once I'm in the template and I've selected my tenant, Brown, there's a little import button here. And I'm going to click on it, and it's going to say, where do you want to import from? Well, in this case, this tenant only lives in Amsterdam, so it's my only choice. If he was living elsewhere before in many sites, I would have to choose. But right now, I'll just keep it easy. So I'm going to click AMS, and I get presented with a box. And this is basically a set of choices about what objects we want to import. We can import everything. We can import some things, but not others. You know, you have choices. So in this particular case, at the top level, I want to import the application network profile. This one happens to be called AN1. When you click it, notice there's this column over here that says include relations. Well, what are the relations? Underneath this application networking profile are two EPGs, two VRFs, two bridge domains, blah, blah, blah. Let's go down to the next level. And because this box is ticked, you see all of these are turned on as well and ticked. Right? I can turn them off here if I didn't want them. Like I just wanted one EPG but not the other. But now I actually want both, right? Contracts. Well, right now neither of these EPGs actually has a contract deployed. But yeah, I want to bring this guy in. And I want to include relations as well. So that means filters are automatically going to be ticked. If I didn't have this, if I turn this off, notice the filter is no longer checked. I can either check it here, or I can say, go ahead and bring all the filters with that contract. The VRF, I don't want V1, I just want VRF V2, right? So with that, I've done my thinking and said, these are the objects I want to import. We'll go ahead and import, right? So now notice it already set these up for Amsterdam because it was the only site that we had selected. In fact, it's our only choice at this moment, right? And notice here that we've imported these objects, but you see there's a problem here because I think what I did, and that's okay, is bridge domain A was mapped to the wrong VRF. So it's mapped to VRF V1. Well, we'll fix that, no worries. We'll go here and we'll say, nope, you are now a bridge domain part of V2. So I'll fix that little error, but you see the little red popped up and it told me this is something that you have to fix. And then also, I think, what was it here? The contract is saying, I don't, actually, I must have not brought the association with it, but I've got the filter there, so I'll just go ahead and fix that and say save. So when you see red, it means you need to fix something. You need to correct something, right? And then we're ready to go. We can deploy to sites, right? Let's look at our bridge domain. We can see that at the site-specific level, it brought in our subnet. There's BDA. That's that subnet. There's BD stretch code there, and off we go. We just need to deploy. So we'll click up here, and we will deploy to sites. Now, this is basically saying these are all the objects I'm going to touch. And this is, when it says created, seems a bit confusing, but what it's saying is MSO is going to touch those objects for the first time. So from MSO's point of view, it's created, even though these objects already existed in APIC. So that's okay, that's normal. So we'll go ahead and click deploy. Everything was successful. Going back here, we can see that if we go under BD stretch, there's my multi-site warning. There's my little icon. all of these things are now owned by Multisite Orchestrator. Good. I'm trying to think, Max. I don't want to connect anything yet. I just want to build the
Not
template.
yet, because we're going to cover now the control plane, data plane, so you can do that after.
Yeah, so I think what I'm missing here for tenant Brown is I have to build I'll build this first, and then what I'll do is I'll take BD and EPG stretch, and I'll actually stretch them, and I'll show you what that looks like, okay? So let me quickly do BCN. I should probably script this, but okay, you get to see it again, just so that you have it. Now, I'm not going to import anything because right now I'm just doing specific to Barcelona. So V2. This is what we already done before, so don't get scared that I'm going fast. And I think we're good with that. Let's map this guy. Gotta click on him. Add sites. Oh, see now, okay, I always make this mistake, and this is probably a good thing. Where's Barcelona? And does Brownfield actually even live in Barcelona? Well, let's go check. He does not. So I've made a human error. A human error. How do I correct that? So let me close the Brownfield template for just a moment, and we're going to go back to sites or tenants. Sorry, we're going to go back to tenants, and there's Brown. Click on the little dots. Edit. I need to make sure I tell MSO that this tenant needs to live equally in both sites. So I just corrected that. I always do that, and I always kick myself, but maybe it's a common mistake that you might make, and now you know how to fix it. So schemas, Brownfield, we'll go back here, edit. Now we can map this guy to his proper site. And here, I think we need to set network. I think this guy is 3.1/24. Save, deploy. I'm going fast, but this is just repeat. Ooh, look, warning. This is good I made this mistake. VRF v2 associated with BDBCN is not deployed to this site. How are we going to do that? That's an interesting one. Let's think our way through this real quick because there is an answer. I want something to live equally in both sites. What's a good way to do that? Well, let's create a template that covers objects that live in both sites. So I'm going to create a new template. I'm going to select my tenant Brown, and let's leave that right now for the moment, right? Because VRF v2 already exists. How do I tell MSO that take a VRF that currently only lives in Amsterdam and make it live in both? How am I going to do that? Well, where does it live today? It lives in Amsterdam, right? There's VRF v2. How do I say he lives in both? Well, that's good because what we're going to do is we're going to migrate and stretch this one. So I'm in the template for Amsterdam, and instead of clicking import, I'm going to click select. So when I say select, what it does is it adds these little checkboxes here, over all the objects or groupings, and says which objects are we talking about that you want to move or migrate. So I'm going to say this guy, I want to move. No, not delete. I forgot, Max. Once I select it, where's the?
Sorry, Joe. Say again.
Sorry. Once I select it to move, I forgot. It used to be.
Yes, you go back to the dots on the top right next to cancel.
Oh, right there.
And it will give you the option to migrate.
Oh, but I don't. It only says delete.
You need to select them. If you select them, which EPG and BD are you trying to move?
I'm trying to move a VRF.
No, you cannot move a VRF. As I covered in the lecture, for now, the move is only EPG and BD. Okay, the other object like VRF is something that we will need to move, support it in a future release.
I am sorry about that. Then I made the
So
mistake.
when you imported it, and I got distracted, I apologize. When you imported it from Amsterdam, like I discussed this morning, objects are supposed to, that you knew they were supposed to be stretched, like VRF, you should have imported directly into a stretch template, right, or a common item template, whatever you want to call it. So
Okay,
now
so-
you can move it in the sense you delete and you recreate it, right? But
yeah,
that's what you
exactly.
have to do.
Exactly. So this is an ID 10T error, you know, and Joe's an idiot error, right? So let's go ahead and delete that.
But it's a good point, right? Because as you said, if you make mistakes, it means someone else will also do it, because I have done the same, right? And you guys need to keep in mind that, you know, most likely if you import a tenant in a site, because you want to extend connectivity for the tenant in another site, it's good to think, okay, well, to do that, probably VRF is one immediate thing that I want to map to a stretch template, right? Because it will definitely need to exist in both sites. EPGs and BDs are the objects that are movable now, because are the ones that likely can be moved more frequently because you stop stretching or you start stretching stuff. But the VRF
Okay.
normally is always stretched, right? Yeah.
Thank you. So I guess silver lining, we can learn how to avoid this error in the future. So you'll notice I deleted the VRF and immediately my bridge domains went red because, well, there's no VRF associated anymore, at least in the policy, right? I haven't pushed it yet, right? So what I'm going to do is I'm going to go here to common items, this new template that I just created, and I'm going to go ahead and create VRF v2 again to correct my mistake. Then let's back over here and let's just make sure we reestablish that mapping. If I have any more red there, I have to do it there as well. Okay. I think we're good to go with that. So I'll deploy this to sites. Where was I going with? I need to do. This is a good point as well. When I click deploy to sites, I was at the Barcelona level. I need to make sure that I do it at the Amsterdam level as well. You can see here, there's my thing, and reestablish. So now everything's green. So if I go back here, everything's right. So if I go, BDA is still associated to VRFv2, right? So I fixed it. The thing that I wanted to show, to really show here is I wanted to first create these, which I think I just did, and then I want to take this BD stretch and EPG stretch, and I actually want them to live in both sides. So this is where I was going with the select and move. So how do I do that? Well, you already kind of have an idea. So back in the template where these objects currently live, which is Amsterdam, clicking on select, I want BD stretch and EPG stretch to live equally in both sites, right? So when I click yeah, so I want them to live equally in both sites, because right now if I go to Barcelona and I go into Tenant Brown, there is no BD stretch. There's only BD BCM at the moment, right? So I selected what I want to migrate, and then I'm going to click on the three dots, and the new option shows up of migrate objects. So when I click on migrate objects, it says which schema. Well, I'm only working with Brownfield here, and then which template. Well, I want this to also move over to Barcelona. Actually, no. Oh, I screwed up. I screwed up again. What have I forgotten to do? I'm a little bit off my game today. I apologize. I didn't ever add my sites. Let's fix that. Yes. Now we go here. We say select. Get it right, Joe. EPG stretch. BD stretch. Now we migrate. And now we say schema brownfield, common items, and off we go, right? So now note what the sanity checker is telling us is these three objects used to only live in Amsterdam with this template. Now we're moving it to a template called common items, that's already been mapped to both of our sites. So we're going to be adding that, and that's exactly what we want. And when we say yes, why?
You basically migrated and it tells you unable to find BD. You may have hit a bug. I mean,
I think I need
which
to do
reason?
this, right? Make it stretch first.
To migrate now, you could migrate first and then stretch it and then move it. Actually, it doesn't matter, right? You can move it and then stretch it, or vice versa. But I'll be honest. Are you running 301?
Yes.
Because I opened up a couple of bugs around the EPGBD migration in 301. So it may be that, let's see, if you hit a bug, we move on, because it could be that you hit an issue in the logic, in the migration logic. So try again. Okay. Yeah. You're hitting a bug in the migration logic. So this is usually due to some still entering the database, maybe because, it's the setup that you have been playing with. I don't know. I would say let's move on. They understood the point, right? And obviously this is usually working fine, bugs apart, right? But I've been testing it many times without any problem. Sometimes, and as I said, I open a couple of DDTS. It's mostly related to stale object in the database. Sometimes, depending on the sequence of operation, you may end up
what I will do, Max, is as you go to the next lecture, I will troubleshoot and figure out how I can get it working so we have this in fact working.
Yeah, exactly.
Okay. And I think that's where I wanted to end up. So you want to, what I'll do is I'll stop the recording, and I think I will hand back to you for the next lecture.
All right. Yes.
And I will fix whatever, I'll work around this bug somehow. Let me start the recording again.
This meeting is being recorded.
All right. So there was quite a bit of lab work, right, to basically walk into the import, the template, the schema definition, the definition of the object. Now, I hope you got an espresso, because this part here is quite beefy, right? Because we're going to go into the details of how actually multi-site work at the infrastructure level, at the networking level, right? I know most of you probably are also very networking oriented, right? Here we're also I'm going to talk about how multi-site work, how do you extend connectivity, how can you establish layer 2, layer 3 connectivity between the sites. But I think one of the most important points that I want you to take away from this section is the concept of namespace normalization and shadow objects. And I'm saying this because many people are still confused by shadow objects. We have seen customers opening tag cases because they didn't understand that some of the objects created were actually shadow objects, right? So I want you to understand what shadow objects are and why we use these shadow objects, why we went into the route of implementing this shadow object functionality. Okay, that's, to me, it's one of the most important points. The rest, how do we communicate layer 2 or layer 3, something that you can also find and read in the documentation, right? So it's networking in the end of the day, okay? So let's start with that part, the namespace normalization. First of all, one thing that we didn't probably explicitly said, but hint to, for multi-site, to add the fabric to a multi-site domain and to connect the fabric to the inter-site network, we need to run second generation spine. Second generation spine means modular spine with the X or FX line card, or non-modular spine like 9332C, 9364C, 9316D. Okay, we cannot support multi-site with the first generation spine, like 9336PQ, for example, or non-EX FX line card for the modular, which instead could be used for Multipod. Okay. Now, this first generation spine can still be used inside the fabric, but only for intra-fabric forwarding, as you see here. The only links, the only interfaces you can connect out are interfaces that belong to the second generation spines. And when you combine Multipod and Multisite, I don't have a slide showing that, but it's an important point to clarify. Each pod, part of the Multipod fabric, needs to have at least one second generation spine when you want to do Multisite from that Multipod fabric to connect to the Interset network. Okay? So you cannot have one pod with second generation spines and the other pods with first generation and using the transit services of one pod. Each pod needs to be connected with a second generation spine. Okay, why that? Not only because we want to sell customer new hardware and them refreshing and give us more money, but there are actually two technical reasons. One is the use of ingress replication, which is what, as we said, we used for sending bump forwarding traffic. The second reason is for namespace normalization, okay, which is a key functionality of Multisite. Why do we need namespace normalization, and what do we mean with namespace normalization? So the idea is, as I told you before a few times, for establishing site-to-site connectivity between endpoints connected in different fabrics, we use VXLAN. We built VXLAN tunnels between these sites. Okay, and we will see in detail how this VXLAN tunnel is, where is it initiated, where is it terminated. But the point is, we carry metadata information with the VXLAN packet, and that metadata information that we carry, it's basically give us information about networking construct like VNID. That VNID value could be an L2 VNID for bridge traffic, an L3 VNID for routed traffic, right? So identifies the VRF or the bridge domain, where the source endpoint usually belongs to, okay? And then there is the class ID. Class ID usually identifies the EPG that the source endpoint that generated the traffic belongs to. Why is it important to carry class ID and VNID? Is because it allows us to basically ensure that we don't need to reclassify the traffic when it comes to the new site, but we already know the network devices already knowing which forwarding table, layer 2 or layer 3, to do a lookup based on the VNID value, and also what kind of policy to apply based on the PC tag or class ID value. However, if this was Multipod, the story will end up here. Why? Because VNID and class ID values across all the pods that are in the same epic domain are consistent, right? If I have an EPG red, that EPG red is associated to a BD red. The BD red gets a VNID. VRF gets a VNID, the EPG gets a class ID, and these values are consistent across all the pods because I have a single epic cluster assigning this value. In Multisite, we have different epic domains, and these different epic domains are truly independent from each other, which means what epic domain 1 assigns to an EPG red, is not necessarily the same attributes or the same values and resources that epic domain 2 assigns to the same EPG red. And let's make an example to understand. Consider this case where I have site 1 and site 2. In site 1, I have an EPG green, which is only local to site 1. It's no stretch, right? It exists only in site 1. In site 2, I have an EPG yellow that only exists in site 2. What I want to do, I want green to be able to talk to yellow, right? It's normal inter-site connectivity between local EPGs. So I go on my multi-site orchestrator, I create my policy, right? I have my single pane of glass where I create my policy, and I say, I want red to talk to yellow with this contract, okay? I push that policy to both epic domain. What happens when that policy is pushed to epic domain 1 and epic domain 2 is that we basically recreate in each epic domain the same relationship green, yellow, and contract, okay? Which essentially means in site 1, we need to create an EPG yellow because the EPG yellow normally does not exist there because it's locally existing only on site 2. And in site 2, we create a green EPG to recreate the relationship, right? Because green did not exist in site 2. This yellow in site 1 and green in site 2 is what we call shadow EPGs. They are really created only for the sake of assigning resources and identifier to them, like the class ID for the EPG. We create also shadow object for the bridge domain, and if needed for the VRF, in case I do an inter-VRF communication. And the epic in site 1 will assign these values to the shadow EPG yellow, and the epic in site 2 will assign its own set of value to the green EPG, to the shadow green EPG. Now, if you compare what the real EPG gets in site 1 and what the shadow EPG, green EPG, gets in site 2, you see that these values are not consistent, right? They are independent because they were assigned by two different epic domains, right? So we need, when the traffic is sent from site 1 to site 2, and it carries the information that identifies the green VNID and the green class ID in site 1, before that traffic is injected into site 2, we need to translate these values, that means green in site 1, with the corresponding value that means green in site 2. Why? Because we don't want to assume that the values are consistent, right? One approach could have been, okay, whenever I create an EPG and I create a contract with an EPG in another site, MSO needs to go to both epic and say, okay, go to the second site and say, is this network ID available, right? Is this class ID available? It may not be, right? The class ID 49153 that we use for green in site 1 may be used already in site 2 for something else, right? I don't want to rely to have to configure a consistent class ID across different sites, because that will basically prevent brownfield integration, et cetera, okay? So what we need is the spine to basically translate the VNID value and the class ID value carried in the packet before injecting the packet into site 2. And that's what the spine does. And we want the spine to do this line rate. We don't want to have any performance implication, which is the reason why we basically need the second generation spine, because the ASICs in the second generation spines can perform this header manipulation line rate, okay? And in order to perform that manipulation, the MSO instructs the epic to properly configure translation tables in the spine. And when you look at the translation table, in the spine inside 2, I have translation entries for the green EPG, bridge domain, and VRF in this case. In the spine in translation 1, I have the translation table to handle the traffic in the opposite direction, from site 2 to site 1. Okay? So, in a nutshell, every time you want to establish inter-site connectivity between EPGs that are locally defined in each site, you need to ensure that these translation tables are properly populated. If you did not populate these translation tables, the data plane traffic would break, because the spine would not be allowed to send the traffic into the fabric, because you may start mixing traffic that goes to destinations that are not supposed to be the destination that you are intended for, okay? And this is basically the reason why, if you want to establish inter-site connectivity between across the inter-site network using VXLAN, the policy must be defined on MSO, because it's defining the policy on MSO that also ensure that MSO will communicate to epic, get from each epic domain the proper class ID, VNIDs that the epic associated, and then communicate that information to the other epic. And so the other epic will then go and configure properly the spines. Okay? So there is lots going on under the hood to allow this inter-site communication. You're not supposed to do anything for that. This will just work, and the multi-site orchestrator has a way for you to basically check that the translation table has been properly populated, okay? And Joe will also show you how you can check that on the spine CLI if you want. But the important point is that if the EPGs are not stretched, this translation table population is triggered by the creation of the contract between the EPGs, as I show here, or if the EPG and the BD are stretched, just in virtue of stretching that EPG and that BD, the translation table will be properly populated. We will see that another couple of scenarios where the lead to the creation of the translation tables is the use of preferred group and BZNE. And translation table population always map to the creation of this shadow object, right? So what people get surprised with, and again, I want you to walk away from this understanding this, is that while in site 1, you never explicitly went and create a yellow EPG, that yellow EPG will show up in site 1 as soon as you go on MSO and you create this contract green to yellow. Same thing for the green EPG in site 2. And this is something that usually creates issue with people that did not understand this behavior, because they're like, okay, well, I just apply a contract to an EPG in Site 2, and I saw something popping up in Site 1. Why is that? Well, because as a result of the contract, you basically created a relationship that caused the creation of a shadow object in the other site. Now, this shadow object today, they look like the regular object, and Joe will show you. We added actually a description, and I think in 301 that Joe runs, the description is there that will tell you if you click on an EPG, which is a shadow EPG, it will tell you this is a shadow object, right? And we will see when Joe show you the lab, and we will point that out to you. In the next release of Epic and MSO, so in a release 4 to 5 of Epic code and 302 of MSO, when you do that combination, we will actually change the behavior, and by default, we will hide the shadow object. So in this example, you will not see in Site 1 the yellow EPG, you will not see in Site 2 the green EPG by default. But there will be a global flag that if you click it, will basically expose and show you the shadow object, right? And again, we put that in because we want people to understand how the system works in case they need to troubleshoot, but we don't want them to be to open entire cases because they're like, oh, I push something to Site 2 and I create an object in Site 1. Why? Okay? It is expected. These are the shadow objects. Okay? So hopefully this is clear, but again, the creation of shadow object and corresponding population or translation table is the critical piece that allows the east-west communication to work. If you have an east-west communication issue, 9 times out of 10 is because for some reason the translation table have not been properly populated, right? For a good reason, because you made a mistake in configuration or because potentially a software bug, okay? Now, in terms of connectivity, I already touched upon this, so I'm going to go fast. You can use Multisite to establish pure layer 3 communication across sites. This is the case where you have an EPG red and a BD red in Site 1 and an EPG green and a BD green in Site 2 in the same VRF in this example. As I showed you in the previous slide, you apply a contract and you create your shadow object. The shadow object in this case are the BD and the EPG that are created for red in Site 2, and for green in Site 1. Okay. When you deploy your bridge domain to basically configure this use case, you will configure the bridge domain red to a template associated only to Site 1 with L2 stretch not enabled, right? Because I want BD red to be only local in Site 1. And I configure the BD green in Site 2 also with L2 stretch not enabled because it is local to Site 2. Okay? Another use case where you have layer 3 communication across sites intra-VRF is the one of the stretch EPG. So here the use case is I want EPG red, and in this example also green, to be stretched across sites. But I don't want the corresponding subnet of the BD red to be stretched across sites. In other words, EPG and points of EPG red sitting in Site 1 will be part of subnet 1, and points of EPG red sitting in Site 2 will be part of subnet 2. Right? The end result is endpoint-to-endpoint communication inside EPG red will be free because it's the same EPG. So from a policy perspective, it's free communication, and it will be routed, right? Because it's subnet to subnet. Okay? It does not matter if it's bridge or routed. It's an intra-EPG communication. To communicate with green, I will need a contract, right? And this is regular ACI. Now, the key point is that to configure this use case, you need to ensure that the EPG red is part of a template which is stretch, because I want EPG red to exist in both sites and stretch across the site. But also BD red, I'm going to put it in the same stretch template. Why? Because I want the same BD red object to exist in both sites. What I don't want is to basically extend the subnet, right? And so I will configure the BD red in a stretch template, but I will not enable the L2 stretch. This basically, the end result is that BD red is instantiated in each site because I've mapped the template to the 2 sites, but then I can go at the site level and configure a different subnet on the left and on the right. If instead I define a BD as L2 stretch, the subnet becomes a property of the BD, and so it is the same, is assigned at the template level because it needs to be consistently the same across sites, right? So if I enable L2 stretch flag, I stretch the subnet. Okay, hopefully this is clear because it's a similar use case that we do with the extension with the public cloud. Okay, where you can have a stretch EPG, but not a stretch BD because we do not extend layer 2 to the public cloud. Okay, I can also do routing connectivity between EPG and BDs that are part of different VRFs. If I do that, it's the usual configuration or route leaking configuration that you need to do on Epic, right? That you are probably familiar with on ACI, actually, that you usually do on Epic. Requires to configure the subnet under the provider EPG. No difference here. And as a result of that, the route will be leaked from VRF1 to VRF2 and from VRF2 to VRF1. And as a result of that, shadow object will become created in each site. In addition to the BD and the EPG, also the VRF, shadow VRF, will be created in this case, right? Because VRF2 may not exist at all in Site 1, and VRF1 may not exist at all in Site 2. So it is created as a shadow object, okay? And so also in this case, the BD are configured as L2 stretch disabled. When do I enable L2 stretch? There are a couple of use cases, okay? The one on the bottom, which is, I usually define the smartest way, a more advanced way to extend layer 2, is by stretching the bridge domain without enabling the BAM forwarding, right? So I want to extend the subnet. I want to allow vMotion and also IP mobility between the sites, cold or hot mobility, without joining the flooding domain, okay? That's what I said at the beginning. If something bad happens in the layer 2 domain in Site 1, that flooding does not propagate across the site, okay? We can do that with ACI Multisite because of the control plane that allows to exchange reachability information, so we always know where the endpoints are connected. We don't need to flood, right? We flood in traditional legacy network because a layer 2, because we flood when we don't know where something is. We need to flood to be sure that the packet reaches the endpoint, and then I learn where it's located. In ACI Multisite, we know where each MAC and each IP is connected. And if we don't know, we have a ARP gleaning function that allows us to find out, okay, and wake up a potential silent host. And that should work pretty much flawlessly, okay? So my recommended way when you need to stretch layer 2 should be the bottom one. As I said, there are some cases where you want to stretch also and extend the BAM forwarding, and this is really when you need pure layer 2 connectivity, not even IP intra-subnet, but I'm talking pure layer 2 non-IP communication between nodes, between endpoints, right? Again, all the application clusters, stuff like that. But should be the exception, right? Not the rule, and maybe it's great if you don't have that requirement at all, okay? All right, now, a little bit more into the control plane and data plane consideration. Joe already showed you how to configure this, right? When you attach a site to a fabric to the multi-site domain, you need to specify these specific addresses for the spines, right? This is important because these are the addresses that basically will allow the establishment of EVPN control plane and enable the data plane forwarding, right? The overlay unicast step is what a fabric always used to receive and sort unicast traffic. The overlay multicast step is what a site always used to receive flooding traffic, BAM traffic originated in a remote site, okay? So in order to establish the control plane, overlay control plane EVPN, and overlay data plane, the VXLAN data plane connectivity, we need to allow to build the TCP session for EVPN and the session for the VXLAN packets, okay? The UDP session or UDP packets or VXLAN. So I need to ensure that these values, again, let me go back, this EVPN router ID, overlay unicast step, and overlay multicast step that I define for each site are actually exchanged between fabrics, okay? And these, as we said before, are exchanged by using OSPF. Are sent out of a site, if you want, by using OSPF. Now, in reality, out of the fabric, we don't only send these values, these specific /32 addresses that I showed you in the previous slide. We also send the original TEP pool, right? What I call TEP pool 1 and TEP pool 2 here, these are the original TEP pool that are being created during the fabric bring up, right? When you specify what is the TEP pool of this site. And then it's used to assign loopback addresses to the leaf and spine that are connected to the fabric internally. So that TAP pool is only used for forwarding inside the fabric. You should never have to use or to terminate any tunnel to a remote TAP pool, internal TAP pool of a remote site. Okay? So then you're wondering, why do you even send it out to the spine? Right? Just keep it in. Well, we send it out because you may have a combination of multipod and multisite. And for multipod, we need actually to exchange the internal TAP pools between the pods, because in multipod, we establish a tunnel always leaf to leaf, right? So leaf in pod 1 needs to know how to get to the destination TAP of the leaf in pod 2, okay? So in order to generically work, no matter if you have multipod as a fabric or not, that TAP pool is advertised, which means our recommendation is if you have a true multi-site deployment on the first ISN device, you can filter the original TAP pool. You don't need to send it in the intersite network. Just drop it there and just allow to exchange the specific EVPN router ID and overlay unicast step and multicast step, right? The easiest way is if you have a different protocol running in the intersite network compared to the OSPF that you run with the spine. And that's usually the case. OSPF with the spine, and then I usually have BGP in the intersite network, or I can use a different OSPF process and redistribute between the two, right? If I have a redistribution point, A, I'm more granular, I can control what I send. B, I avoid sending information that may be, I mean, it's not harmful to send the original TAP pool unless this TAP pool has been chosen in a way random that maybe conflicts with some information in the routing table that you have in the intersite network, right? If you use a dedicated VRF for multi-site, no problem, right? Because you doesn't matter. But if you don't, you want to ensure that you drop that TAP pool as a best practice recommendation, okay? So once you have done this, basically the information is exchanged and the leaf will know how to get to the overlay unicast step of the remote site. That we will see is what you need for forwarding to work. Once the underlay information is exchanged, the first thing that happens is the EVPN control plane is established between the spines, right? TCP session is established spine to spine, EVPN router ID to EVPN router ID. Now, this control plane can be used to exchange the endpoint reachability information, but how does it really work? Remember that differently than multipod, we want to ensure that in multi-site, we don't send across sites the information for every endpoint that we discover, right? Because otherwise, the overall scalability of the multi-site domain in terms of endpoint would boil down to the scalability of a single fabric, okay? So what I mean is, let's say I connect endpoint 1 that belongs to EPG Green to site 1. That endpoint 1 is discovered by the leaf. I send a COOP notification. This is regular ACI discovery. The information for endpoint 1 is added to the COOP database of site 1. I do the same thing. I connect an endpoint 2 in the yellow EPG in site 2. I discover it. I add it in the COOP database of site 2. Now, if this was multipod, just the fact that I add it to the spine database would basically trigger an EVPN update because all the spines in all the pods need to have a consistent view of where the endpoints are connected because it's logically a single fabric. We multi-site, we do not exchange any information across sites by default until you actually go on the multi-site orchestrator and say, you know what, I want green to talk to yellow. Now, defining the contract between green and yellow, or for example, stretching one of the two EPG, right? It's an indication that, wait, okay, if I do this, it means my intent is that I want to enable inter-site connectivity, and at that point, the EVPN control plane will kick in and will communicate information for the endpoints that have been locally discovered in this EPG across the sites, okay? Now, to be 100% technically correct, the granularity is not at the EPG level, but it is at the BD level, right? So if you add another EPG in site 2, EPG blue, part of the same BD of the EPG yellow, at the moment I create this contract, I will start sending also the endpoint blue to site 1, okay? But if you have a network centering approach where an EPG is a BD, then it's correct to say that in this case, only the green endpoints will be communicated to site 2, and only the yellow endpoint will be communicated to site 1, okay? And that allows the spine to populate the COOP, the COOP database, and basically associate, as you see here, all the endpoints discovered in site 2 with a single IP address, which is the overlay Unica step address, identified site 2. And the other way around, all the endpoints in site 1 are seen from the remote site as reachable through a single IP address, which is the overlay Unica step A address, right? So that's the beauty of multi-site. It shields the specific leaf step information, and everything that is connected to a site from the external fabrics is seen as reachable by a single IP address. So a site is seen as a single IP, okay? Which simplifies the forwarding and the troubleshooting of flows in the internet network, as we'll see in a second, okay? So we enable exchange of underlay information that allow to build the EVPN control plane. We created a contract that, or we stretch an EPG that allow to exchange endpoint reachability information. At this point, I can enable my data plane. And if you're already familiar with this, I apologize, but I cover it for the sake of, it's also the recording, right? It may be useful to people. So let's say I want now green to talk to yellow, and green generates a packet destined to yellow. And let's assume the yellow is initially unknown on the leaf in site 1. You know that with ACI, by default, we don't know any endpoint at the leaf level, right? We learn endpoint information only from data plane activity, right? Receive traffic from the remote endpoint. So initially, when I do a lookup in my routing table, I don't find or actually my endpoint table in site 1, I don't find any information for yellow. That means two things. One is I cannot apply policy because I have no idea which EPG the destination 2020 belongs to. Point number two, when I do a lookup in the routing table, I find that, okay, I don't know the specific, but my routing table says that to reach the subnet 20, I need to send the traffic to the local proxy, which is basically an IP that a TAP that identifies all my local spines. This subnet 2020, which is associated to the bridge domain yellow that exists only in site 2, is configured on the leaf in site 1 as a result of the creation of this contract, right? If you didn't have the contract, the subnet 20 would not be known in site 2. In site 1, sorry, will only exist in site 2, right? But the moment I apply a contract, we install it to point to the spine. Why? Because I point to the spine at this point can do a lookup. He finds EP2 because he learned EP2 from the control plane, as I showed you in the previous slide, and now he can encapsulate the packet to the site where he knows EP2 is connected. So the packet is encapsulated, the destination in the VXLAN header is changed to overlay Unica step B, and we also change, the spine also changed the source IP address in the external VXLAN header to be overlay Unica step A. Because remember, inside the inter-site network, all the communication between endpoints that belong to site 1 and site 2 is always seen as a communication between the IP address that identifies site 1 and the IP address that identifies site 2. So overlay Unica step A to overlay Unica step B. Okay? So the packet now gets to one of the destination spines. They all own the same overlay Unica step B loopback and address. So one of them will get it based on routing. That will do a local lookup, will know that EP2 is connected to a local leaf, so it will change the destination to be the leaf inside site 2, where the endpoint has been discovered. And when the packet gets to the leaf in site 2, in the destination leaf, two things happen. Point number one, I'm going to learn the endpoint information for EP1, right? Remember that the spine changed the source address to be overlay Unica step A. So now I know the EP1 is associated to the site identified with overlay Unica step A. Point number two, since in the packet I'm carrying the class ID that identifies my green EPG, I can now apply the policy. Okay, I apply the policy. If the policy allows, I send the packet to yellow. The policy, for example, could say redirect to a firewall, or could say drop, or could say allow. Okay, and now the packet gets to EP2. When EP2 responds, now the difference is, actually, so let me go back. So from a tunneling perspective, the source leaf encapsulate to the local spine, spine encapsulate to spine, spine encapsulate to remote leaf. Okay, so we basically stitch together these tunnels. Now, when the yellow endpoint responds, now on the leaf inside 2, I know where my EP1 in the endpoint table, I know where it's located, right? It's located to the site identified by overlay Unica step A. As a consequence of that, the leaf can actually encapsulate directly, create a VXLAN packet directly destined to overlay Unica step A. When the packet goes across the local spine, the spine that handles it still changes on the fly the source bit to be overlay Unica step B, because again, the communication needs to be seen in the external network only as a communication between A and B. When the packet gets to the destination spine, I do the lookup, send it to the local leaf. At this point, I don't need to apply the policy in site 1 because I was already able to apply my policy in site 2, right? Here we're talking about regular policies, right? If you're talking about service graphs, there are some specific considerations that we'll cover in the service insertion section, okay? So the packet gets to the leaf, I learn the location of EP2, and then the packet is forwarded to the destination, okay? So from a encapsulation perspective, I go from leaf in site 2 directly to the spine in site 1, which also need to perform the translation and namespace normalization, right? The translation based on the translation table, as we discussed before. And then I create another tunnel, spine to local leaf in site 1. And from this moment on, since I populated the endpoint table in both leaves, I will be able basically to encapsulate in the two directions, leaf to remote spine, remote leaf to local spine, right? And that's how basically the tunnels are always stitched in a multi-site communication once we learn the endpoint information, okay? Specific consideration for the BAM traffic, if I enable the BAM forwarding, and only if I enable the BAM forwarding, when an endpoint part of the EPG green, which is stretched with the BD green is stretched with the two BAM forwarding enabled, the BAM packet is first distributed inside Site 1, inside Fabric 1, using multicast, right? We have different multicast trees associated to a bridge domain. Then one of the spine is elected as designated forwarder for that bridge domain and is responsible to do ingress replication. So create one copy for each BAM packet and send a copy of each BAM packet to each of the remote sites where that bridge domain has been extended. In this case, it's just 2 sites. So I create my BAM packet and I send it to the overlay multicast step B that identifies all the spines in Fabric 2. When the spines receive, one of the spines receive it because all of them own that overlay multicast step B address, and then forward the packet inside the fabric associated to the multicast group that the bridge domain green has inside 2. Obviously, that multicast group that I use for green inside 1 and I use for green inside 2 are completely independent from each other. They may be probably 2 different multicast groups. I don't care because they're stitched by an ingress replication function in the middle. Okay? And that's how the packet then will get to the EP2, right? Like if they were connected to the same VLAN in the same switch. But they could be actually in the opposite side of the world. Okay? Now, for layer 3 communication only from the site, as I told you, multi-site can be used, VXLAN can be used to enable that L3 communication. The question is, why can't I just do something like this, right? And this is also a question that I always ask. Why can't I just enable layer 3 communication between the sites using the L3 out, right? In other words, the green bridge domain subnet will be learned via the L3 out, the green inside 1, and the red subnet via the L3 out red inside 2. And I have some customers that they introduce MSO, but they don't want to use the VXLAN data plane, right? That's absolutely doable if all you need to do is layer 3 communication between the sites. Just keep in mind that what doesn't allow you to do is to basically go on MSO and say, okay, what I want red to talk to green, right? You need to go on MSO and actually say, I want red to talk to the external EPG in Site 1, and I want the external EPG to talk to green in Site 2. So you need to stitch together 2 contracts in this use case to allow red to talk to green. I would argue that from a policy perspective, what you really would like and what customer would like to do is actually to say, I want red to talk to green with this policy and not having to worry where red and green are actually located, right? Could be in the same site, could be in different sites, okay? And that's the power of using the VXLAN data plane. But if you want, or if your customer wants, they could use this just for layer 3. If you need layer 2 extension between sites, then MSO is a must. We do not recommend anymore what we used to call the dual fabric design, where we were using, for example, OTV to extend layer 2 between the fabrics. That's a design that we don't test anymore. has never been validated in the last 4 years. You may discover bugs, right? So truly discourage your customer from doing it if they need layer 2 extension. For only layer 3, I actually have customer with multi-site orchestrator in production that they started just enabling layer 3 communication through the L3 output, right? It works, obviously, without any problem with the consideration that are on this slide, okay? I'm going to skip this because it's a very detailed thing that you find in the multi-site paper anyway. I want to cover 2 more things and then give the ball back to Joe. I hope you understood that no matter if you want to enable layer 2 communication or layer 3 communication, the key point is the creation of the shadow object and the population of the translation tables, right? So way to populate the translation table or to trigger the creation of the translation table is stretching an object or creating a contract between non-stretch objects. In reality, there are 2 more situations where these shadow objects are created and translation entries are created, and they are the use of preferred group.
Max, sorry to interrupt, but
Yes,
your slides might be lagging a little bit. We're seeing the simplified policy application segue slide, seg slide.
You're seeing?
What slide are you on?
Okay. I am in simplified policy application, yes.
Okay, okay, because it was lagging a bit.
Yes.
I just wanted to make sure we were back in sync. Okay, thank you.
Let me know. I'm going to move to the next one now. Let me know if there is a delay. So preferred group and BZN are 2 configuration options that also leads to the creation of the translation entries in the spine, which is the reason why we needed to add implementation to MSO to basically drive that creation of translation entries when these knobs were created. Preferred group and BZN has been supported in ACI for a long time, BZN from the very beginning, okay? What we were missing was the support of this construct on MSO. And preferred group came from release 202. Again, you just need the MSO release. In ACI, preferred group has been there for quite some time. What preferred group is used for is used when you want to enable intra-VRF configuration, communication, between EPGs that are part of the same VRF, and you don't want to have to configure a contract so that the EPG can talk to each other. So you want to enable free communication, you want to use ACI as a multi-site, in this case, as a networking solution to establish connectivity between endpoints, okay? Now, in that case, what you can do, you can go and put the EPGs part of the preferred group. There is one preferred group that can be defined for each VRF, and the EPGs that are part of the preferred group, they communicate with each other freely. You don't need a contract between green and red, green and pink, or pink and red. When they want to communicate with an EPG, which is outside of the preferred group or is not part of the preferred group, I need the regular contract, as always, okay? So this has been available in ACI for a long time. In MSO, has been introduced in release 202. Up to from release 224, we increased the number of preferred group that we supported. They used to be 250. I believe now it's 1,000 or 500. I think I need to update this slide. I think it's 500, but you can find that value on the scalability guide, right? And why did we need to wait to have this supported in multi-site? Is because the creation of a preferred group configuration that now you can do on the multi-site orchestrator basically triggers the population of the translation entries, right? Why? Because I want green and yellow, and in this case, the external EPG, to be able to talk to each other freely, no matter where green, yellow it is, right? And if green and yellow happens to be in different sites, I need a translation table populated to allow that communication, right? So driving that translation table population through the preferred group configuration was something that had to be implemented on MSO, okay? And that's how basically it works today. You can test it, it works pretty well. The second option that we brought in MSO from release 224 is VZN, right? What is VZN? VZN is a logical construct, okay? It's not an EPG. It's a logical construct that represents all the EPGs that you have defined in a given VRF, okay? So all the EPGs that you map to a BD that is in a VRF, they are part of this VZN club, okay? Now, why is it useful to group together as a single logical object all the EPGs in a VRF? For 2 main use cases. Use case number 1, I want to establish a many-to-one connectivity relationship between the EPGs in a VRF and a shared EPG, a shared service, right? The shared EPG could be in the same VRF or could be in a different VRF, okay? So if I want to do this, I can actually create a contract, C1, and I can say my VZN consumes the contract which is provided by this shared EPG. As a result of that, EPG green will be able to talk to the shared EPG based on the contract. EPG blue will talk to the shared EPG. Red will talk to the shared EPG, all based on that contract. I don't need to configure 3 relationships. I configure only one, and it scales better, it uses less TCAM entries, and the end result is the same. Okay? This doesn't mean that red can talk to green and to blue, right? Inside, between them, you still need a contract. There is no preferred group, but all of them can talk to the shared EPG. Okay? So this is a many-to-one use case. Now, the second use case, which is an alternative to the use of preferred group, is actually defining a contract, which is a permit any contract, like with a filter that says allow everything, and then having VZN consuming and providing that contract. If you do this, the end result is that all the EPGs inside the VRF are able to communicate with each other freely, right? Exactly the same thing that you would do by putting these EPGs in the preferred group for that VRF. So it's an alternative approach to preferred group that uses actually a policy, right? Uses the contract C1, but allows at the end to apply the same contract C1 between all the EPGs in a VRF. And normally it's because I want to allow free communication. Another use of this is not to allow free communication, but redirect all the EPG to EPG communication inside the same VRF to a firewall, okay? And the problem is that works, but works only in a single fabric. In Multisite, today, in the current release, which is actually 3.01, that contract that you see there, C1, can only be a contract with a rule, right? With a rule, permit any, or whatever rule you want, but I cannot attach a service graph to that contract, okay? It's a limitation due to the way we do service integration with Multisite. But as long as you define, and this is true also for the use case on the left, as long as you apply a contract with a rule that is enforced at the fabric level, you could use the use case too to enable free communication if you wanted inside the VRF. Okay? And as a result of both use cases, right, what's going to happen? Surprise, surprise, we populate properly the translation table so that we can have east-to-west connectivity based on the many-to-one or based on the any-to-any communication paradigm that we want to put in place. With this, I told you it was a beefy section, so I'm going to stop here and give the ball back to Joe that will show you most of this concept actually in practice, right, so that you can solidify your knowledge.
Yep. And I also figured out what went wrong with my last demo. It was not a bug in MSO. It was a bug in Joe's clever manipulation of the wrong things. Because I have OCD, I really quickly want to just do that last part. I'll do it fast because we know. So let's make me presenter first.
Yeah, let me stop sharing.
Yeah, I got it. And make sure I'm sharing my terminal. And I'm sharing PowerPoint. Okay, really quick. Okay, so where I screwed up, right? Will be on this guy. So remember, I had imported. Let me go back. I had imported all of this stuff. Then I built some Barcelona-specific stuff. But what I really wanted to do was stretch BD and EPG across. So I wanted to first do this, which I'm already done, and then stretch this. So let's actually show you that. So here I am back in my schema brownfield. Where did I go wrong? So what I did here was I brought in, what I first did was I created a template of common items, and I first imported, the only thing I imported was the VRF into common items, right? Then what I did was I imported all the stuff from Amsterdam only. So you'll see that the VRF is not here, it's living here. That's where I went wrong. So now, because Max told me, you can't move the VRF and all that stuff. So now at this point, what I want to do is I want to take EPG stretch and BD stretch that only currently live in Amsterdam. You see, it's Amsterdam only. And I want to move them to be stretch. So go to select, take EPG stretch like before, BD stretch, click the three dots, migrate, select brownfield, select the common items template. We say OK, just like before, and we say yes, and it's successful. And what I need to do is I just need to deploy, and it worked. So it was a Joe error. I just wanted to show you it wasn't a bug in MSO. I didn't want to unfairly besmirch the greatness of MSO. So now, if we look at AMS only, that EPG is not there because we just moved it to this template. We migrated this to a different template that lives equally in both sites. So now if we go to Barcelona and we see there's BD stretch and there is EPG stretch there as well, okay? So it's now equally living in both sites, right? So I did manage to quickly achieve this, which is good because I kind of need this working for my next demo. So let's talk a little bit about what I'm going to do in this particular demo. So this is control and data plane in action. So we did all the work building up our templates and our schemas, but I haven't really connected any endpoints because I wanted to show you how this sort of evolves in ACI. So first I'm gonna take my stretched EPG and BD, right? And I'm gonna just establish connectivity, right? It's the same EPG, so I shouldn't need any contracts. That should allow them to communicate very easy. Then I'm gonna turn on intra-EPG isolation via multisite orchestrator, so I'll show that to you. Then I'll turn that back off, and what I'll do is I'm gonna show you shadow objects. So what I'm gonna do is I'm gonna take my AMS clients, which lives in Amsterdam, and talk to BCN servers, which lives in Barcelona, apply a contract. I want to show you the spine translation tables because Max went through a lot of slides, and sometimes even I get confused because there's so much going on those slides. I'm like, I think I got it, but I'm not quite sure. But let's have a look at what it looks like from the point of view of the spines when this actually happens. And then I'll show you also that I can do live migration across sites. I'll keep a ping going. I'll vMotion a VM. Everybody will be talking. Then what I'll do is I'll finish up by showing you quickly preferred groups and VZ-any, right? So this is the stretched EPG that we currently have. So what I need to do is I need to connect these two endpoints and just make sure that they can talk. And then what I'll do is I'll do intra-EPG isolation. So very quickly, let me put these guys into their right port groups. So I have some VMs already pre-configured. I need to put them in the right port groups. So AMS EPG stretch for this guy. Just want to point out, sorry, this is stretch in site 1. See right here? Just want to point that out. And then this guy lives in site 2, stretch 2. And let's move him into, oh, you know what? I didn't map it. So let's fix that as well. So I migrated it, but I didn't map it. So if I go here to EPG stretch, down at the Barcelona level, what I failed to do was do the VMM domain mapping. We'll quickly fix that because we know how to do that. And save and deploy. That was a site-specific mapping to the DVS in site 2, if that makes sense. So now this will work. Changing the port group to EPG stretch. Yeah. Let's open up the remote consoles for these guys. Sorry, I'm not going fast, but let's just make sure they can. No, I don't want that. Okay, what's his address here? He is 192.168.4.10. Yes, let's just make sure he can being his default gateway. And he can, that's good. Demo gods are favorable right now. Let's go to the device in site 2. Exit loads. Take its own sweet time. Let's have a look at this guy. Who is he? His IP address is 4.30. Yes, let's make sure he can ping his default gateway, right? And it's not.
Joe, you need to share the console window.
Thank you. Sorry about that. So this, just to kind of catch you up, this is the guy in site 1, and this is the guy in site 2. And because I'm nervous with like hundreds of people, I forgot a secondary mapping. Because here this bridge domain stretch. Oh, I didn't set the bridge domain to stretch. That's why it's not working. Let me fix that.
And now, as you just to add to, you see that the subnet becomes a multi-site property, right? That is configured at the template level, right? Because once you stretch, all the sites need to have the same subnet.
Yes, now it's working. Okay. So sorry. Thank you. So I wasn't showing my thing. So I have this particular guy is a endpoint that lives in site 1. He is in EPG stretch. He is at address 4.10. This guy over here, his IP address is 4.30. He is living in site 2, but belongs to the same stretched EPG stretch, right? So can 4.10 ping 4.30? That's the moment of truth, right? So can he ping 4.30? And he can. So what does that prove? It proves that my control and data plane are actually working. Let's quickly look back in an ACI. When you have things in the same EPG, right? Just in any ACI operation, multi-site or not, if you live in the same EPG, you don't need a contract, right? So simply by EPG membership, you can speak. So let's actually look at the control planes of the spines. Let's actually look at site 2 because I think I've got that set up. So if I go into the COOP database, I want to look at the COOP database of the spines. So if I go here under Fabric Inventory Pod 1, I go under the spine itself. I go over to protocols. It takes a moment to load always. Come on. There we go. And then COOP, open down, and here's the endpoint database right here. So if I look in the endpoint database in spine in site 2, we can see I've got entries for both 4.10, 4.30, right? Because they're in the same EPG, a control plane exchange has already happened just by being in the same EPG. That lets the spines know, hey, listen, I know about the reachability for both sides. What does that look like in the spine in site 1? So what I've done is I've logged into the CLI because I wanted to show you a different way to look at the COOP database. And the command that I use is show COOP. Yeah, come on. Okay, show COOP internal info IP-DB. Now, if I just type that command, it will show me the whole COOP database, which isn't that big, but I'm just egrepping for IP address. And if I hit return, you will see that this is the spine in site number 1, and you will see there's 4.10 and there's 4.30, right? So we know control plane messages have been exchanged between the spines and the sites to tell each other about reachability for endpoints, right? That's a pretty simple example, right? Now what we should do next is I have my pings going. Let's ping in the other direction. We'll just see 4.10. So my pings are going right between these two guys in the same EPG. Now I want to turn on intra-EPG isolation, right? So what's intra-EPG isolation? I have everybody by default in the same EPG can talk without anything special happening. But let's say my security posture changes, and now I say, yeah, even though all these web servers or whatever, these endpoints in the same EPG, yeah, they belong in the same EPG because they get the same sort of contract application and networking, but they really shouldn't be talking to each other. They should really only be talking to other EPGs. So I want to turn on a pVLAN like function, which is yeah, intra EPG isolation. So how would I go about doing that? So let's go to our EPG, right? And if no, that's yes, I'm sorry. So at the template of common items, right? At the EPG, which equally lives in both sites, down here on the right, intra EPG isolation, by default, of course, it's unenforced. But if I click on enforced, right, it's going to actually say, hey, listen, I'm purposely going to block communication now from members of that EPG. So I'll say yes, deploy to sites. We're modifying this time from, if you see, unenforced to enforced, and we'll deploy. And in just a second, we should see, yeah, our pings have stopped. Yes, because inter-EPG isolation is in fact working. So again, I think Max mentioned this, but one of the goals of the MSO UI was to expose a lot of this tenant level policy configuration, but make it really easy just by clicking a button. And there might be a few things that happen in the background, but you don't care about that. All you care about is the result. And so in this case, it's really quite easy to enable intra-EPG isolation. So let's turn it off because I actually want them to start talking again. So it's as easy as the radio button, deploy to sites, modifying it, and if we give it a second, there goes our pings, right? Our pings are back, right? Just to show you that this is in fact working, right? Now, let's put these two guys aside for the moment, and I want to work with a few different endpoints, right? So now what I want to do is I want to work with this guy over here. I think maybe I'm using .11 now, but I have an endpoint over here, and he's attached to client's AMS, right? I've got another one over here, right? And I actually think he's 110. I have to double check him. I think what I'm using here is, this is 11 and that's 1, 3. Anyways, EPG over here in client's AMS needs to talk to an EPG over here in a different network, in a different EPG. So now we're using that routed use case. I don't yet have a contract, right? So I just want to show you here that in my application EPG, notice I only have, in the Amsterdam point of view, AMS clients and EPG stretch, right? So if I go to AMS clients and I look at the operational tab, here's Win8 Silver at 1.11, right? That is this guy right there. I can triple click without it unclicking. If I go to Barcelona and I go back to my tenant Brown, let's look at the application profiles. I only have BCN servers here, right? Because it's the only, it lives uniquely in Barcelona. And if I look at its operations, there is Win8 site number 2 at 3.110. Yeah, so that is this endpoint right there. You follow me so far, right? So now let's look at the Coop database, right? Let's go back and look at the Coop database of Barcelona real quick. Takes a moment for protocols to open. Going into the endpoint database, let's look at it. So there's 3.110. Where is 192.168 1.11? Well, he's not currently known to site number 2 because we have not enabled a contract, which would then kick off a control plane message that would then update this guy and say, these people can talk, here's how you reach them, and put an entry in the Coop database. The same thing holds true if I go look at the spine and I issue that command as well. You'll see that here is 1.11 in the Coop database, right? But I don't see 3.110 because, again, no contract. This is normal at this point. I kind of want to show you the before I apply a contract, right? So Coop databases are different, and the existence of objects are still site specific. Now let's actually apply a contract between them. So what I'm going to go here is I'm going to go to AMS only, and clients is going to consume a contract. I have a contract here called C1, and I'll make this guy a consumer. I'm going to go to BCN only, and there's BCN servers. I'm going to attach that same contract, C1, as a provider. Okay, I'm going to say save. I'm going to have to deploy. I'm going to have to deploy this one, and this one. Deploy, right? Now, what has happened? We don't need these guys for the moment. We have Win8 Site 2 and Win8 Silver, which lives in Site 1. Just make sure these guys are in the right... No, they should be in the right port groups because we already checked that. So let's just make sure he can ping his default gateway, and he can. He can ping his default gateway, which is a different network on 3.x. Can they ping each other? So just make sure my address is, he's 1.11. This guy over here is 3.110. Can he ping across? Because now we have a contract. And it's working. The contract has now permitted communications between EPGs. That's a normal ACI concept. But now let's go back here and look at the COOP database of the spine in site number 1. And if you see, 3.110 shows up in the COOP database, just like over here, 1.11 has now shown up. What happened? Well, because that contract has tied these two EPGs together, Multisite Orchestrator has pushed the config, and that triggered the spines to trade BGP messages to say, these guys can talk, here's your reachability, update your endpoint database so that we can actually make communication happen, right? So these are things like, I show you these things because when you look at Max's slides and he's talking about all the NCAP, DCAP, spine translation, sometimes I get lost. I get lost. So when I see it happen in the COOP database myself, I go, okay, now I understand what just happened. So I hope I can express that to you as well. If we go into the spines, speaking of translations, right? Max showed a bunch of slides about when you create bridge domains and VRFs and EPGs in a given site, they're given unique identifiers like VNIDs and S classes and all that business. Well, the sites are different, meaning the numbers that get handed out for things is different, right? So let's go ahead and look back what's going on at the tenant level back in APIC. So I'm in APIC in site number 1, right? Notice a couple of things that have happened. Things got added. Where did they come from? What are these things? Well, I'm in Amsterdam, and now I see what bridge domain BCN showed up. What's that all about, right? I see this application network profile called BCN with BCN servers show up. Well, I'm confused because BCN servers doesn't live in Amsterdam. BCN servers lives in Barcelona. What's it doing showing up in the APIC in Amsterdam? This is another area where people get confused, right? These are what we call shadow objects. This is what Max was talking about. This is probably...
And Joe,
yeah,
just to point out, if you look at the description on top, right? In this version with... sorry. I wasn't sure. Okay, go ahead.
You took the words out of my mouth. It's okay, Max. So that's the thing is, this is probably the first or second most common mistake that people make with multi-site is they miss the differentiation between a local object and a shadow object. And the way you can tell is there's this banner at the top that Max just mentioned is, this is a shadow object. Don't touch. Don't make any changes, right? We need to have these shadow objects exist because if I look at Barcelona and I go back to Tenant Brown, and if I look, you can see that there's some Amsterdam clients existing at the same thing. This is a shadow object. We need these shadow objects to complete the equation, so to speak. And I'll try to kind of explain this, right? So forget about multi-site for a moment. Just think simple ACI with 2 EPGs. when ACI logic, when you say an endpoint in EPG1 wants to talk to an endpoint in EPG2, we need a contract, right? So what we do is we look it up in the policy TCAM and say, is there a contract, consumer provider, between these two EPGs? EPGs get assigned what are called S classes. They're just a numeric identifier so that computer logic makes sense. Computers like numbers, not words, right? So we assign these S classes, right? And so it says, can this S class talk to that S class and using which contract, right? So the idea I want to impart here is there's two sides to the contract. There's the provider, there's the consumer, and there's the contract in between. In this case, now if you bring in the notions of multi-site, is we still need to have that looking up logic to say, can this EPG talk to that EPG? So by creating the shadow object, it's like a empty placeholder so that the logic can be programmed to say Amsterdam clients can talk to BCN servers. And so we create the corresponding shadow objects. So locally, the leaf whose job it is to do the lookup and say, can this guy talk to that guy or that girl? The logic, the pieces are in place to make that happen. So I'm going to pause there and let that kind of sink in. That's the importance of shadow objects, right? If we look at, let's say let's look at, I think we can do it here. Yeah, this is a good way to look at it, right? I am in the APIC that is in Barcelona, so site 2. And I'm looking at the bridge domain called, this local bridge domain called BDBCN. It has been given a class ID, right, of 32770. Yes, that is the ID handed out to this particular bridge domain, right? I can look at the same thing if I look at the application EPGs. I think, no, actually I should have been up here. No, I guess it's, oh no, I'm sorry, right there. That's where I wanted to go. So if I look at BCN servers has been given a class ID of 16386 from the perspective of Barcelona, right? Let's go look at Amsterdam real quick. And let's go to the same thing. We'll go and look at the resource IDs and we'll look at that EPG. So BCN servers is known from the perspective of Amsterdam with a different class ID of 32773. So you're probably confused a second. So this is where the shadow objects come in and the translation that the spines do comes into play. So if we were to go back to a spine, right, and we were to issue a command, I think I already, yeah. If I type this command, show DCI manager repo S-class maps, right? This is from the spine in Amsterdam, right? What was my 32773? So 32773, this is the local column here on the right? So 32773, PC tag is locally known as 32773, right? Remotely, the spine is already programmed to know that on the remote side, this exact same EPG happens to be known by a different number, 16386. So the spines have a very important job here to translate. As as packets need to flow between EPGs, we need to know their true class ID or their S class and what they're known as on the far side, right? How can I say, like, when I'm in America, I'm known as Joseph. When in Spain where I live, they might call me Jose. I'm the same guy. I just have two different names. So it's kind of like, the spines are actually translating to say, if you're trying to talk to Joseph, you really want to talk to Jose if he's in Spain. I hope that didn't confuse people more. But I just kind of wanted to show you. There's another command if you want to look at, let me go up. If you want to look at VNID maps, so this is VRFs, right? So here we have a list of VRFs, right? And BDs, right? So locally speaking, let's go back here. Let's go back to VRFs. VRF B2, from the perspective of Amsterdam, right, is known by, what is it? The 386, right? This guy right here, right? What is that VRF known by in the remote site? Well, it's known by this number. Again, maybe the conclusion here is don't get too caught up in the fact that the translation is happening, because it's all done for you automatically. There's nothing extra you need to do. But the thing that Max and I want you to understand is that it is happening. But don't get caught up in the numbers and the how. This is just us showing you the job that the spine is doing for you. It's already done for you, right? Don't have to worry about it. But when the time comes, if you get into some sort of really deeper troubleshooting, you might want to say, okay, what's this VRF known locally here? What's it known as remotely? Those kinds of questions can come up. So I want to show you these commands. The last command I want to show you is show DCI manager repo ETAPS. This is basically telling the spine, what do you see about how to reach the far side spines? I don't know if that made sense in English, but basically from the spine in site 1, he's saying if I want to send a unicast packet, that's the address I would use, 33.33.33.20. I don't know if you remember, because a lot of things have been flying by, but remember from my cheat sheet, that's the overlay unicast TEP for site number 2. If I want to send multicast or bump traffic, I have a special TEP address for that, because we do head-end replication for that kind of traffic, and it is known as at 33.25. And is unicast? No means it's the multicast TEP. Yes. So that's another easy command to sort of see, like, how is the spine in one site seeing how to reach a spine in a different site? Right. I hope that makes sense, right? So yeah, so we have our ping. Everything is working well. So what do I want to show next? I think what I want to show is yes, I want to put a contract now. I want to put this contract between um, all of my EPGs. So let's go back to MSO. Basically, want I want Amsterdam clients to be able to talk to not only BCN servers, but I also want them to be able to talk to EPG stretch. So what I'm going to do here is I'm going to apply the contract here. Let's make them provider, right? And deploy to sites. So now, not only can he reach 3.110, but he should be able to reach anything in 4.10 or 4.30, right? So the contract has now been added so that everybody can talk. So what I want to do, the reason why I want to do that is, right, I want to keep a ping going to 4.10. And if you remember 4.10, this guy, this Ubuntu in site number 1, let's ping in return to 1.11. So I've got some pings going between these guys, right? So just for sake of clarity, this guy right here is pinging this guy right here, and vice versa, right? I've got a ping going amongst these two different EPGs because I applied the contract. What I'm going to do is I'm going to vMotion 4.10 from site 1 and move him over into site 2 and show you that, well, it's number one, that it's possible, but that I'm not going to lose what maybe more than one ping, probably, right? So we'll try to keep these visible, that the pings are going. Let's kick off a vMotion right now. This guy, right? He's on a host in site number 1. Let's migrate him. Change compute resource. This is the host in site number 2. And of course, we want to keep him in the same EPG. We don't want him to change EPGs. That would break communications. But we want to change sites. So we'll make it high priority. Finish. This is kicking off. Let's go here. We can still see that, pings are going, right? You can see that the numbers are actually changing. Yes. And it's almost done. I think we're not losing any pings. We're not losing any pings. And of course, it's taking its sweet time, but we're almost there. Like once it gets past like a certain percentage, it will just finish. Ping's still going. Ping's still going. Come on. It just shouldn't it shouldn't take this long to vMotion. Yeah. Well, things are still going. Oh, come on. I said just change compute, right? I didn't say storage, did I? This should be already done. I don't know what's going on between these guys, but the vMotion is happening. Not losing pings. I don't know, maybe VM tools. Of course, the demo gods are not with me today. Let's let that one sit. We'll come back to it in like just a second. We'll see if pings are not working. So so by applying a contract between all these guys, communications were allowed, even between stretch or site relevant sort of EPGs, right? So while we wait for this one to finish, God, which annoying because this was working before just fine. What I want to show next before I pass it back to Max, or maybe we take a quick break, is I want to show you preferred groups and I want to show you VZNE. And I sincerely don't know why it's taking this long. It should have already been done. But of course, my pings are still going. Here's what we'll do. I will, oh no, because I'm going to be using these same virtual machines. Okay. Waiting for,
Failed.
fail. I don't know why that happened. Let's do it from this guy the other way. Because you know what? The demo gods are not my friends today.
It's VMware's fault.
Yeah, I heard that. Yeah. No, 1.11. And he should be 4.30. Let's try it the other way around. We're going to move this guy from site 2. We're going to migrate him over to site number 1. We will keep the same EPG. Next, high priority. Bring this up. Going a little faster. See, going 57% already. There we go. Done. Right? Did we lose a ping? No. Lost one ping. We lost one ping. Okay. So I don't know why that one didn't work. I'll blame it on VMware. But I just did the other one the other way, and it's fine. So now you got it, right? You proved that vMotion can work. I know Max is going to ask me to show you one thing about why. Why is vMotion working there? If you remember on my bridge domain stretch, I have this L2 stretch ticked. So the BD exists equally in both. I have layer 2 adjacency, that's what I'm saying. But what I haven't done is allow bum traffic flooding. That's important to point out because this allows us to get the best of both worlds. We can do things like vMotion, which are very important, but we don't necessarily have to pay a penalty of establishing layer 2 adjacency and carrying the baggage of bump traffic. Okay, so that's something to be aware of. Let's really quickly go on to preferred groups, right? So what I want to do here is I want to remove the contracts from clients and servers. So I'm removing the communication here and we'll deploy. So right now, this guy cannot ping his friend over there at 3.10, right? That's AMS client cannot ping BCN server. Now, what I want to do is I want to put them into a preferred group. So what would I do? So if I click on the EPG at the template level, right, there's a thing at the very, very, very bottom. It says include in preferred group. So I'm going to tick that box. Notice a little icon appears that says, this is a visual indication that he is now a member of a preferred group. So I will deploy that to the sites. I'm going to make the same thing. BCN servers also be in the same preferred group by ticking the box, deploy to sites, and you'll notice it'll take a second to program, but this guy should, yeah, there you go. He's pinging now. So what is a preferred group? Just a reminder, we know that default ACI behavior is different EPGs, you require a contract. However, if you want to take a select group of EPGs and give them communications without a contract, you can put them in a preferred group. So you can have one per VRF, but any EPG, you can have multiple EPGs be preferred group members, but any member of the preferred group will be able to speak without a contract. So it's a more granular way to allow the free flowing of communication where you want it without giving up the control point of contracts elsewhere. That makes sense? So I'll stop that. Now, what the next thing I want to do, and this then we'll take a break because I know we've been going for a while, is I want to show you VZNE. So it's important to point out that at least currently you can't have preferred group and VZNE at the same time, one or the other. So I need to disable preferred group, but we already know that that is a trivial understanding. So let's just make sure that gets pushed. Max, question: can you turn this off if you didn't want it? This sanity checker, or is it always
What
on?
do you mean?
When you deploy and it brings up the extra window that gives you a second chance
Yes.
to review, can you turn that off?
No.
No. Okay.
And we don't want to because it gives you, an extra time to really think, is this what I want to do, right? So
Right.
Pushing and deploying could be very scary. Right?
Okay.
There was actually a question about that. Yeah.
Okay. Thank you. We don't have any contracts. We don't have any preferred group. But what I want to do is I want to do VZNE. We know VZNE lives at the VRF level, so I'm going to go to where my VRF v2 lives in common items. I'm going to click on there. As of MSO 424 and later, we enabled this feature. So if you have 423 or I'm sorry, 223, I'm confused, but I have 224 and later in MSO. If you have 223 or 221, you're not going to see it. So don't get confused if it's missing. It's in MSO 224 and later. Okay. So if I tick VZNE, you'll notice it now allows me to apply contracts. Now, VZNE is if you don't remember what it is, it's instead of applying contracts at the EPG level, right? You can apply contracts at a higher level, at the VRF level, and any EPGs that are attached to bridge domains under that VRF will automatically use that contract. Now, it's a more efficient way to deploy contracts that everybody needs. What do I mean by that? Let's say you had 1,000 EPGs, and all you wanted to do was allow ping between them all. Well, if you didn't have VZNE, you would have to go to 1,000 EPGs and attach provider consumer contracts 1,000 times. Would it work? Yes, but it would be extremely wasteful of resources because you'd have 1,000 plus TCAM entries burned for just something stupidly simple like ping. Well, there's got to be a more efficient way, and that's why VZNE comes into play, because you say for the types of contracts that everybody should get, like I want to allow DNS, NTP, ping, and SSH for management, and everybody should get those ports available. You're going to do this at the VZNE level. So, and it's very efficient because it would only consume the TCAM resources one time, not 1,000 times, even though 1,000 EPGs might be making use of it. So in this case, and what Max showed on his side is you can do one to many, or you can do many to many, right? So one to many would be, I maybe have a provided contract on a server EPG, and then apply the consumer side to the VZNE, which would allow anybody to talk to that server EPG, or I could just do any to any, which is what I'm going to do now. Take my contract C1 and make it both consumer and provider, which is legal. And basically what that's going to do once I push it is allow everybody to talk to everybody else. Like doesn't really matter, no restrictions in this particular case. Anybody can talk to anybody. So there we go. I've just deployed it. And in a second, once it gets programmed, now we can see pings have started. Okay. So that's VZNE. And it's quite simple. You do it under the VRF level and you apply your contracts and off you go. All right. So I am going to stop sharing. I'm going to stop the recording and we need to take a break. So it is 3:50. Can we come back at 5 minutes past 4? So about 15-minute break. And then we'll finish up with layer 3 outs and service insertion, and then we'll be done. Sound good?